When you build a tool for a multi-turn conversation platform, or MCP, you're not just writing code, you're making a promise that your tool is going to be reliable, stable, and do exactly what your users need it to do. So how do you actually keep that promise, especially when things get complicated? Well, the answer is all about contract testing and CI, and we're going to dive into exactly how it all works.
It really all comes down to this. You can go down one path, which leads to broken integrations, late-night bug fixes, and, frankly, some very unhappy users. Or you can have a system that basically heals itself, catching problems long before they ever become, well, problems. The big difference is treating your contracts like they're sacred and then protecting them with automated testing that runs all the time.
And this is exactly what we mean by a promise. Your schema isn't just some dry technical document. It's a public declaration. It's you telling every single client, hey, if you send me data that looks like this, I promise I'll give you a predictable result back. It is the absolute foundation of trust between your tool and the people who rely on it.
I mean, really think about it. What happens when a schema changes without any warning? On the other end of that connection, things just break. Integrations fail. Important workflows just grind to a halt. And pretty quickly, users get frustrated. And that trust you built, it starts to fade. Broken promises in software have very real consequences.
Okay, so how do we avoid all that chaos? How do we build a system that makes our promises practically unbreakable? Well, it all starts with a solid foundation. You need a structured testing strategy that becomes the very bedrock of your tool's reliability. So take a look at this. This is the test pyramid, and for MCP tools, its shape is everything. See that huge base? That's right. A whopping 70% of our tests are contract tests. Now, why so many? Simple. They are lightning fast and super focused. We can run thousands of these little guys in seconds to check our schemas, our inputs, our outputs. This is that stable foundation that lets us move fast and build cool new things without constantly worrying about breaking what's already there. With that foundation in place, it's time to get specific about the terms of our contract. What are the exact promises we're making to our users? Let's walk through the 5 essential checks that make sure our contract is always being honored. You can think of these 5 tests as the non-negotiable clauses in your contract. They make sure the promise itself is written correctly, that it works when it's supposed to, that it fails gracefully when it should, that it delivers what it said it would, and that it actually helps you out when something goes wrong. Let's break them down one by one. First things first. Before we can test the promise, we have to check the contract itself. Is it even written correctly? We use a validator to make sure our schemas are properly formed. It's kind of like proofreading a legal document for typos before you sign it. A simple mistake here can cause chaos down the line. Okay, once we know the contract is solid, we test the happy path. This is the most basic promise of all. Does the tool actually do its job? We give it perfect inputs, exactly what it's expecting, and we just make sure it runs successfully. This confirms its core function is working just like we advertised. But here's the thing, a truly great tool isn't just about what it does right, it's about how it handles things when they go wrong. This test is absolutely crucial. We intentionally throw bad data at it, like a junk email address, and we check that it not only fails, but fails with a specific kind of error. This is what prevents nasty, unexpected crashes. And after a successful run, we have to inspect what comes out the other side. Does the result actually match the promise we made in our output schema? This test is all about making sure clients get the exact data structure they were told to expect. No surprises, no last-minute changes. And finally, when things do go wrong, a good contract comes with good customer service. This test makes sure our error messages are actually useful. A good error should tell the user exactly what's wrong, like pointing out an invalid path, so they can fix their request without having to guess. Now, running all these tests by hand is a good start, but it's just not going to scale. To really build and maintain trust, we need an automated promise keeper. And that, my friends, is where a CI/CD pipeline comes in, enforcing our contracts on every single change automatically. This is basically our assembly line for trust. Every time a developer commits new code, the pipeline automatically kicks off this whole sequence of checks. It validates the schemas, runs our 5 essential contract tests, checks how it plays with other services, and, this is a big one, it makes sure we haven't broken anything for our existing users. If any single step fails, the bad change is stopped dead in its tracks. And here's what that looks like in the real world. Every time a developer pushes code, it triggers this automated workflow.
The code gets sent to a system that runs our entire test suite, acting as a tireless guardian that checks every change against our promises before it's allowed to move forward. Now, within all those tests, some are more important than others. These are your golden test sets. They represent your most critical, non-negotiable user workflows. If one of these tests fails, it's a code red situation. It means a fundamental promise of your tool has been broken, and it needs to be fixed immediately. Okay, so we have a system for keeping today's promises, but tools have to evolve, right? So how do we introduce new features and make changes without destroying all that trust we've worked so hard to build? Let's talk about future-proofing our contracts.
A huge part of this is managing version mismatches. So, scenario 1, an old client connects to your new server. That has to continue working perfectly, no questions asked. But then there's scenario 2. A new client tries to use a new feature on an old server. It can't just crash, it needs to fail gracefully with a clear error. This ensures a smooth experience for everyone, no matter what version they're on.
Snapshot testing is another powerful safety net we can use. Think of it like this. The very first time a test runs, it takes a snapshot of the correct output and saves it. From then on, every time the test runs, it compares the new output to that original snapshot. If even a single character is different, the test fails. This forces you to be really intentional about every single change you make. And let's not forget, a promise isn't just about being correct. It's also about being fast. A tool that gives you the right answer but takes 30 seconds to do it has still broken an implicit promise of usability. You have to test for performance, making sure your critical tools always respond in an acceptable time, like under half a second. So after all of that, why does this matter? Well, the payoff is huge. You catch breaking changes before your users ever see them. You can refactor and improve your code without being scared of what might break. Your tests actually become living documentation for how your tool is supposed to work. And when something does go wrong, debugging is way, way faster. All of this adds up to one thing. You build a reputation for being reliable. So, to wrap this all up, I want to leave you with a question. I want you to stop thinking of your CI pipeline as just a technical chore that runs tests. Instead, think of it as your automated, 24/7 trust-building machine. Because with every single green checkmark, it's not just passing a test, it's reinforcing the promise you made to every single one of your users.